welcome to another class on investment appraisal. We are moving to a new subtopic, risk and uncertainty in investment appraisal. Kindly let me know in the comment section if you've been following these classes and let me know what you would want me to do better. So because investment appraisal has to do with evaluating future outcomes, there are always risk involved. Okay, so risk is defined as the chance of a loss. Risk is the possibility or the probability that there will be a negative occurrence. Does it make sense? So because you're going to predict your cash flows, you're predicting inflation rates, you're predicting almost everything in investment appraisal. Because of that, you need to consider risk. Now, in investment appraisal, there are 5 ways or 5 approaches to handling risk in investment appraisal. The first method is certainty-equivalent approach. Number 2 is your risk-adjusted cost of capital. Number 3 is sensitivity analysis. Number 4 is the probability analysis. And number 5 is adjusted present value. Right? I'm sure you've heard me talk about adjusted present value in the introduction class, that we're going to start it as a subtopic on its own. So it's kind of broad. It's one of the broad approaches to handling risk, and it's also very examinable. Even the sensitivity analysis is also very examinable. I've seen many past questions where they examine students on sensitivity analysis and on adjusted present value. And of course, this risk adjusted cost of capital, you will see it in almost every SFM exams, right? So let's start from certainty equivalent. So the certainty equivalent is an approach that gives you a certainty equivalent factor. It gives you a certainty equivalent factor, okay? And it is always in percentage, maybe 80%, 90%, any percentage. It could be 15%. And that certainty equivalent factor is what you use to multiply by the cash flows, the expected cash flows that you are given, to get an adjusted cash flow that you now use in your investment appraisal. Okay, so certainty equivalent is looking at the cash flows or the proportion that you are certain of. That's just what it means. So if they give you cash flows in year 1, that maybe in year 1 you get 50,000, in year 2 you have like 40,000, in year 3 you have 30,000, and in year 4 you have 20,000. They will give you and in the question they'll tell you that the certainty equivalent factor, they can tell you that in every year is maybe 80%. It means that they are telling you that they are sure that they are going to get 80% of these predicted cash flows, these relevant cash inflows that they are expecting in the future. So you now say 80% times 50,000, right? That will give you 8 times 5, that's 40,000. So you are now adjusting the cash flows, okay? So these are the cash flows you are certain of. It's now these cash flows that you now discount. You multiply by your discount factor to get your present value, and then you now evaluate your investment. So the certainty equivalent approach is just working based on past experiences, based on historical records of what we've been doing in the past, what we can predict that will happen. That even if we predict that we'll get 50,000 in year 1, we are only sure of 80%. Now, this certainty equivalent, they can give you a single one, or they can give you that in year 1 is 70%, in year 2 is 85%, in year 3 is 50. So that makes sense. Now let's move to the next approach, risk adjusted cost of capital. We have done this in WAC. Okay, now investment appraisal, like I said earlier, comes with risk. So this approach is saying that you should adjust the cost of capital. So if there's an existing cost of capital, like we've already done in WAC, weighted average cost of capital, I'll link the particular video up here. So if there's a particular project or a particular investment that the company wants to embark on, maybe they want to go into a new line of business. Because they are going into a new line of business, there's a risk attached to that business already. Does that make sense? So you need to adjust the cost of capital, because cost of capital is very important in investment appraisal. That's what you use to discount projects. You are using it to bring into consideration the time value of money. So cost of capital is important. So you might need to adjust the cost of capital with the potential risk in the business. Does it make sense? So I don't need to explain that further. You know, risk, you can have your financial risk, right, which is this BE that we've done, better equity or equity better. And you can also have your operational risk, which is the business risk, which is this one we've done. So we've already covered it in previous classes, and that's why those previous classes were necessary for us to get to this point. Now, another important approach is the sensitivity analysis. The sensitivity analysis is also called the what if analysis. What if selling price drops? What's going to happen to our MPV? Because in investment appraisal, the major thing you are concerned about is this project profitable? Is it viable? If it's a positive MPV, I'll accept it, right? So sensitivity analysis is going a step further to know how sensitive the MPV is to the various factors in the investment. There are various factors in investment. You have the sales, they will sell, right, to actualize the investment. They will incur variable costs, fixed costs will be there, working capital will be there, you understand? So this sensitivity analysis, the way to know how sensitive the MPV is by saying the MPV over the present value of the particular variable that you are considering, okay, or the particular factor you are considering. Whatever you've gotten your MPV to be, you would have calculated your MPV. Maybe it is 20,000 naira, and they say calculate the sensitivity of the MPV to maybe sales. So you put your sales here, the present value of sales. That is, you have already multiplied the sales by the discount factor. Okay, so you put the present value of sales here. Let's say you have 250,000 as your sales. So when you do that, you have 2 over 25. My calculator. So 2 divided by 25. That's 0.08. That's 8%. Now, this 8%, what it is saying is that if this sales reduces by 8%, the project will not become viable again. Yes, I said that if this sales reduces beyond 8%, that is, if this cash inflow, because sales now is a cash inflow, so if it drops beyond 8%, this project will not be viable. The MPV will be negative. So now let us solve a brief example that will explain this sensitivity analysis. Let me rub off all of this. So we are trying to do sensitivity analysis. So let's say in year 0 we have initial investment of say 40,000. Then let's say in year 1 to 4 we have sales of, let's say, 125,000. Let's say 125,000. Then between year 1 to 4 we also have variable costs of 100,000. Then between year 1 to year 4 we have fixed costs of, let's say, 10,000. And you are asked that you should calculate the sensitivity. Let's say you're asked to calculate the sensitivity of sales, variable costs, and fixed costs, right? So in some exam questions, they will not say calculate the sensitivity. They just say what is the degree of importance, or what if, they'll put it in a way that you will not know that it's sensitivity analysis they are trying to do. But if you already know sensitivity analysis, you understand that that's what they're asking you. So since they ask you to calculate the sensitivity of these variables or these factors to the MPV, what you first of all need to do is to get the MPV, okay? And to get the MPV, you need to do what? To discount. So let's say you are discounting at 10%, okay? Discounting factor at 10%. For year 0, of course, to be 1.000. For year 1 to year 4, because they are constant cash flows, you can use cumulative discount factor. That's the reason why I used constant cash flows, so that you can just do it sharp. So for year 1 to year 4, you just need to check your annuity table. The discount factor for year 1 to year 4, that is, just check year 4 under 10%. You have a 3.170. Year 1 to 4, 3.170. 3.170. If you do discount factor for year 1, year 2, year 3, year 4, and you add everything together, you get 3.170. This one will be 0.909, 0.826, 0.751, 0.683, if I'm right. That's 10%. 10% is very common. So now that you've got your discount factor, you get your present values, okay? So in year 0, of course, to be 40,000. Year 1, 125,000 multiplied by 3.170. That gives you 396,250. 100,000 times 3.170. That gives you 317,000. This times this, that gives you 31,700. 3.170 times 10,000, 31,700. So you have 7,550. Okay, so this is your MPV. MPV is sum of present values. Okay, so now that you have your MPV, what they asked you was that what's the sensitivity of net present value to sales, right? So you take your net present value, right? Sensitivity of net present value to sales. That would be your what? MPV over PV of sales, right? So your MPV is what? 7550 divided by sales, not the sales value, the MPV of the sales. That's what you pick, right? So that's 396,250. So 7550 divided by 396,250, and that gives you 0.019. So if you move it like this, that's what? 1.9%, right? So the sensitivity of MPV to sales is 1.9%. Now you have to interpret these results that you have, this 1.9%, and it means that if sales, and it means that if this sales value, right, because this is the important factor, if it falls by 1.9%, the MPV will be 0. Do you understand? If this sales falls by 1.9%, the MPV will be 0. If you are saying falls because sales is an inflow, right? If it's for variable cost, which is an outflow, you say if it increases by a particular percentage, the MPV will be 0. So if they say calculate the sensitivity of your MPV to, let's say, initial investment, it will be MPV divided by what? PV of initial investment. This is the initial investment here. The PV of initial investment, this is what you pick. So it's the same 40,000, right? So you say divided by 40,000. So that's 7,550 divided by 40,000. That gives us 18.8%. Okay. That gives us 18.8%. So how will you interpret this one? You will say that if the initial investment increases, because it's a cost, if it reduces, if initial investment reduces, if you don't have to invest much, you're not going to be bothered now. But if this initial investment increases by 18.8%, the MPV will be what? 0. Then if it increases beyond 18.8%, the MPV will be negative and the project will become non-viable. Does it make sense? So if we try to increase this 40,000 now by 18.8%, let's say if you want to increase 40,000 by 18.8%, that would be 40,000 times 1.18, right? 1.188. So that would be 40,000 times 1.188, and that will give us 47,520, right? So let's put that here, 47,520. Let's say this was the initial investment. Let's now cast this. Let's cast this. If we get a positive, if we will still get a positive MPV, you can see we have an MPV of what? 30. We have an MPV of 30. Can you see that? Of course, it's 30 because of approximation. Because even this 18.8 it still had other numbers after it. So maybe if I had multiplied the whole digit by 40,000, I would have probably gotten 0. Do you understand? So the interpretation is that if this cost, initial investment, increases by 18.88%, the MPV will become 0. And if it increases beyond 18.88%, the MPV will become a negative. So you can always do for variable cost, you can always do for fixed cost. Just put your factor under the MPV and always interpret your result because anybody can know the formula, but not everybody can interpret it. Okay, so when you interpret it, you prove to the examiner that you actually understand what you're saying. Now let's go to the next approach, which is probability analysis. So this probability analysis focuses on the average possible cash flows from expected outcome. Okay, so the summary is that they'll give you some probabilities. They'll give you probabilities, like they can tell you that, okay, there's an investment opportunity, and in year one we have a 10% possibility or a 10% chance that will make 8,000 naira. In that same year one, there is also a 20% chance that will make 10,000 naira. There's also a 40% chance that will make 12,000 naira. There's also a 20% chance that will make 14,000 naira. There's also a 10% chance that will make 16,000 naira. So which cash flow should I use for year one? This is still year one. No, they can give you all this for year one. That this is what will happen in year one. They can tell you that in year two we have a 50% chance that will make maybe 15,000 naira. We have a 30% chance that will make 20,000 naira, and we have a 20% chance that will make 18,000 naira. Which cash flow would I use for year two? So that's what probability analysis is saying. So it is the average possible cash flow from these probabilities. Does it make sense? And the probabilities they give you in a particular year, can you see it? They must add up to what? 1. All these digits, they add up to 1. 0.1 plus this is 0.3, 0.7, 0.9, 1. Does it make sense? And that 1 means what? 100%. So because all these probabilities are portions of the total outcome. Okay, so you need a particular value to be your cash flow that you use in year one, that you use to evaluate your investment. Okay, now look at this one for year two. Can you see 0.5 plus 0.3, 0.8 plus 0.2? That gives us what? 1, and that's what? 100%. Okay, so let's focus on this year one. Let's now imagine a question. Let's imagine a question that they said initial investment is, let's say, 10,000 naira, and in year one these are the possible cash inflows, and after year one the project will end, and let's say they ask you to discount at, say, 10%. Then they told you calculate the MPV. So what are you going to do? Now what you're going to do is to get probability multiplied by the possible cash flow. Do you understand? So you say, let me write this again: 8,000, 10,000, 12,000, 14,000, and 16,000. Right? So you say that probability 0.1 times 8,000, that will give you 800. 0.2 times 10,000, that will give you 2 times 1, that will give you 2,000. 0.4 times 12, that will give you 4,800. 0.2 times 14,000, that will give you 2 times 14, 2,800. And 0.1 times 16,000, that will give you 1,600. Right? So you will now add these possible outcomes together. You have married them with their probabilities, then you add them together. So this is 28 plus 48 plus 28 plus 16. That gives you 12,000. Okay, it has put everything into a figure and giving you what? 12,000. So the average possible cash flow, that's what it focuses on, is 12,000. Is this 12,000 you now go and use in your investment appraisal, right? And you know how that one works now. Year 0, year 1. In year 0 there was an initial investment of how much? 10,000 naira, right? In year 1 cash flow, the year 1 cash flow, all these multiple cash flows that they gave you based on probabilities, it has given you 12,000. So you have 12,000 in year 1, right? So you discounting factor at what? 10%. For year 0 it will be 1.000. For year 1 it will be what? 0.909, right? Then your present values will be what? 10,000 negative 0.909 times 12,000, 0.909 times 12,000. That gives you 10,908, right? When you cast this, you have 908 as your MPV. So you have positive MPV. So that's what I'm just trying to explain, that once you have probability in investment appraisal, it's trying to show you that these are the various possibilities. So what you need to do is to multiply probability by those cash flows, the relative cash flows they give you, get the total, the average possible outcome, APC. That's what you take to your investment appraisal. You could have this for year 1, year 2, year 3, year 4, year 5. If the examiner wants to waste your time, and then you bring a particular amount here, and that's what you use in your investment appraisal. Now, the examiner can go a step further and tell you to calculate the risk. Calculate the risk, and that risk is represented as what? Standard deviation. They could also tell you calculate the coefficient of variation. So let's do the two of them. Right? So they can tell you calculate the risk. So how do you calculate the risk? There's a formula for calculating risk, and it's the standard deviation formula, which I believe that most of us should know if we are done, maybe if you are done math and stats or something. So you know that standard deviation, which is the risk, is what? The sum of probabilities of x minus x bar squared, square root. If you remove the square root, it's variance. Okay? But most times they ask you to calculate the risk, which is standard deviation, and this is the formula: summation, the sum of this. So your x is those possible outcomes. These are your x, the possible cash flows. Your x bar is what you've gotten, the average possible cash flow. And if you look at it, it's like your mean. If you remember mean, median, mode, it's like the mean of all this. It just finds a balance, and it found it on 12,000. You understand? So that is your x bar. So x minus x bar, x minus x bar, x minus x bar. Then you raise to the power of 2. That is, you square it. Then you multiply by the relative probabilities. Then you sum everything together. It's very simple. Okay. So the first thing you need to do is to get your what? X minus x bar. X 8,000 minus x bar 800 minus 12,000. That gives you what? Minus 4,000. 10,000 minus 12,000 minus 2,000. 12,000 minus 12,000 0. 14,000 minus 2,000. 14,000 minus 12,000 2,000. 16,000 minus 12,000 4,000. Then you get your what? X minus x bar square. Does it make sense? So if you square this, minus 4,000 times minus 4,000, do you understand? That will give you plus 16 million. So you have your 16 million. This one minus 2,000 square, that will give you 4 million. 0 square will remain as 0. This one will be 4 million. This one will be 16 million. Then you now multiply by probabilities, right? That is probability multiplied by what you have here, x minus x bar square. So this 60 million times the corresponding probability, that's what? 1.6 million. This 4 million times 0.2. 2 times 4 is 8, right? That would be 800,000. 0 times 0. 4 million times 0.2, that will give you what? 800k. 16 million times 0.1, that will give you 1.6 million. When you add all this together, see, sum of this, that will give you what? 4,800,000. Can you see that? I think that 1.6, that's 3.2. 3.2 plus 1.6, that will give you 4.8 million. Right? So you have gotten all that is inside the square root. So you have your standard deviation, which is your risk, if they have to calculate risk, to be square root of 4,800,000. All you need to do is to put that to your calculator. Square root of 4,800,000. And that will give you 2190.8. So that's 2191. So this is your mean. Just write it like that. 2191 units. That's all. That's your risk. Sorry, that's your standard deviation. So we've done this. Now I said they can ask you to calculate the coefficient of variation, and the formula for calculating coefficient of variation is your risk divided by your return. In fact, coefficient of variation here means what? What is your risk per return? Right? Risk over return. And your risk is what? 2191 divided by what is your return? The return now, that's your X bar, what you used in as your cash flows, that's 12,000. So 2191 divided by 12,000, and that gives you 18.25%. Let us say 18%, right? You know, when you get something like this, you have to interpret it. So it means that for every unit of risk taken, there's a return of 18% in this whole project. Do you understand? So that's your coefficient of variation. I hope that explanation makes sense before this class gets too long. The last approach to handling risk in investment appraisal is adjusted present value, APV, which we are going to start in the next class. Like, this one is very examinable. I've seen it in many past questions, and it's like a subtopic of its own. That's why I even mentioned it on its own in our introductory class. Okay, so do well to give this video a thumbs up if you learned one or two things from it, and also share with anybody that you know that will find it useful. You will not have gained value from this video and you will not share it with anybody, right? So thank you so much for watching, and I'll see you in the next class. Bye.